Hello everybody, today we are going to write a program that will count the sum of all numbers from 1 to the number that was entered by the user. And this program seems to be easy to write, but we'll base on that program in our future lectures. So please stick with me because we will learn today lots of very useful things, okay? We're gonna solve this problem in 3 different ways. So when you look at the text of this exercise, the first thing that you should do is probably think about the easiest example that you can write without having to write a program. So for number 5, I want to add 1, 2, 3, 4, and 5 numbers to each other. And the result is gonna be 15. So we want to probably generate numbers 1, 2, 3, 4, and 5 when somebody type 5, right? How to do it? Well, I think the easiest way to do it is use the range function. Range from 1 to 6. Why? Because range from 1 to 6 will give you as the result 1, 2, 3, 4, and 5. 6 will not be included. Okay, that's useful. So we could use a loop for each number inside the range from 1 to 6. And let's print numbers so we are sure that we did it properly. That's how every programmer creates programs. They test. As you can see, 1, 2, 3, 4, 5. Okay, this works fine. And I want to add these numbers. So I think that we could create a variable sum, and we could add to sum itself plus the number. And then we can print the sum. So now when you run the module, as you can see, the result is 15. But how does it work? Well, the sum at start is equal to 0. We can, do something like that. It's equal to 0. And the number is equal at start to 1. Because in the first iteration, it's gonna be equal to the value that is gonna be returned from the range, right? So it's equal to 1. So to sum, we assign sum, which is 0, plus number, which is 1. So after the first iteration, so after the first pass through the loop, sum is equal to 1. And now the number is gonna be changed to 2, and we try to assign to sum itself, which is 1 plus 2, which is now 3. And then we change the number to 3, and what? 3 plus 3 is 6. And again, 4. 6 plus 4 is 10. Number is equal to 5. 10 plus 5 is 15. And then the loop is gonna end because, well, there is no more steps to go through inside that loop. And we return 15. Always, if you do not understand how something works, analyze the loop like if you were a computer. So this is one of the solutions to this problem. And of course, a solution that needs to be upgraded a bit, right? Improved. Why? Because right now we have the values here fixed. I propose to make it inside a function. So we're gonna define a function and we're gonna call it, for example, sum up to. Like that. We can now copy it here. We need to make a proper indents. And we need to somehow set this thing to the thing that is gonna be sent here as argument. So we need to create a parameter that will hold this number here, right? And I think we shouldn't print the sum, we should return the sum, right? Because then it can be reused somewhere. And now, when I run it like that and print the value, I will get the same result, 70. Oh, of course, we need to add 1, that's important. Why? Because the range from 1 to 6 is 1, 2, 3, 4, and 5 without 6, right? So when we type 5 here, without that plus 1 here, you would have numbers 1, 2, 3, and 4. So well, that's why we need to add 1 here. And it's 15 now. Okay, so it's 15 and it works fine. The cool thing now is that we can, do something like that, and we're gonna get as a result, proper result, right? Very fast. So it's pretty cool. But this is just one of the way to solve this problem. There are many others. Let's copy this function and let's make it different way. I told you about the list expressions. They could generate numbers, right? In order to use them, you just type the brackets like that, and then you type what you want to do with the numbers that you're gonna select soon. And then you need to select the number. So for each number inside, I think we can use the same thing that we did here. And the truth is that it's gonna generate the thing that we want, right? 1, 2, 3, and 5. We can check it out pretty easy by doing something like that, right? If we don't believe it, run the module in order to check if everything is fine. And of course here we don't have arguments, so let's do it like that. And as you can see, 1, 2, 3, 4, and 5. It works fine, right? And well, I think we should change the name of that function to sum up to 2, for example, to make it different from that one, because we overrode this function above here. That's why you have none here, because we didn't return anything here, right? So we just generated 1, 2, 3, and 4, and 5. But we want to add these numbers. The cool thing is that we can add them pretty easy by just doing something like that. Sum is a function that is from the standard library, and if you send there an expression, which can be a list expression, set expression, whatever, it's gonna sum all the numbers that are inside. So we can just return this. And I think it's gonna look better when we do it like that this time, because it's gonna be shorter. And when we do something like that, we're gonna get as a result the same result, right? 120, whatever we type here, and the results will be the same. So we made a different solution, and now you might be, what's this faster? What's better? It's hard to say, because, well, you would need to think about exactly what happens in the backstage stage. We will talk about how to time it and what is faster in the next lecture, okay? Let's focus on making another ways. Look, we could even do something like that. Instead of the list comprehension, we can make a set comprehension, or we could make a generator here inside, and the results will be always the same, but the problem is that probably the speed in each time is gonna be different. And of course, we'll check it up in the next lecture. And now I will show you the fastest way that was invented by a very young man who was only 10 years old, as far as I remember. I will tell you a story. In math class, where children were only 10 years old, a math teacher wanted to have some time for himself, and he thought about giving them a job to do, an exercise. They had to add numbers from 1 to 100 and give the result. So the math teacher was like, I'm gonna have probably like 30 minutes, maybe even the whole lesson for myself. Okay, so I can focus on my things. But the problem is that one of the boys came to him after like 1 minute. The teacher was shocked, and he told him that he cheated, or maybe he used the calculator. Whatever he did, it's impossible. But that young boy was pretty smart, because he noticed that when the difference between each number is the same, and when you add the first element and the last element, in case of, for example, like that here, because it's a bit simpler, right? It's better always try something simpler than on hard example. So if you add the first element, this last element, and you divide the result by 2, and then you multiply it by the amount of elements, so 1, 2, 3, 4, 5 elements, the result is gonna be 15, right? 5 plus 1 is 6, 6 divided by 2 is 3, 3 multiplied by 5 is 15. So it's pretty awesome. And really, when you do it for the above sequence, so you do something like that, 1 plus the last element, right, divided by 2, multiplied by the amount of elements, so it's 100 of elements, it's gonna give you as a result a proper result, right? Like if you did it manually, like we did it here, right? 1 plus 2 plus 3 plus 4 plus 5 plus 6. It takes time. This guy was a smart guy, smart boy, very young, and he shocked his math teacher. So we can use it also, why not? So we're gonna define the sum up to 5, like that. And what? We want to add the first element, which is always 1 in our case, because that's how we assumed in our exercise, plus the last element, which is the end, then divided by 2, and then multiply by the amount of elements. We have the same amount of elements as this thing here, right? Because we count them 1, 2, 3, 4, 5, 6, 100, right? So we have the same amount of elements like the last element is equal to. So multiply by end. And we can just return. And when we do it like that, as you can see, the result is the same. You can instantly see that this is the fastest way, right? Because, well, computer must just add one number here, and well, 2 numbers here, divide them by 2 and multiply them. That's just very fast, right? Notice that when we do something like that, right? When we have here over 1000 numbers to add, here it's still the same. You just add 2 numbers, divide by 2 and multiply them. Here, on the other hand, you need to, generate numbers and then send them to the sum function. Well, that must take some time, right? Here, probably it's a bit faster because we add numbers one by another instantly. We do not need to save them somewhere temporarily, right? So this is probably a bit faster. But we don't know which of that which of them is really the fastest and by how much. Because, well, we don't know how to measure it yet. All of that we will learn in the future lecture, and you will see how big impact can make when you know, for example, math. Because the thing that I told you here is called arithmetic sequence, and you learn it on math lessons. Okay, that's only the lesson. Thank you very much.